Okay, this video is going to work with joint, marginal, and conditional distributions, also find means, variances of x and y, conditional means and variances, covariance, correlations. So hopefully this will clear up a lot of questions that people have about sections 4.2 and 4.3. So we're working with a joint probability mass function, little f of xy, and it's tabulated here. Notice that the probabilities of this joint probability mass function have to sum to 1, and they do. Now I'm going to start by finding the marginal distribution, f sub x, of x. So what this is going to do, I have x can take on the values -1, 0, and 1. And what I'm going to do is I'm going to figure out, okay, if I know nothing about y, what is the probability that it takes on each of those values? That is the marginal distribution of x, f sub x of x. And the way I find it is by adding for all of the places that x is -1, add up all the probabilities associated with the different y values. So 1/12 plus 2/12 plus 1/12 gives me 4/12, which is equal to 1/3. The probability that x is equal to 0 is 0 plus 2/12 plus 2/12, which is also 4/12, or 1/3. And the probability that x is equal to 1 is 1/12 plus 3/12, which is 4/12, or 1/3. And this here is giving me my marginal distribution, f sub x of x for all the different values. Okay, now if I want to calculate the mean of x, the easiest way to do it, I could take the value of x times the individual values in the table and add them all up. But it's actually going to be easier to just work with my marginal distribution to find the mean of x. So my mean of x, which is the same as my expected value of x, I can find by adding up over all the values of x, x times the marginal distribution, marginal probability that x takes on that value. So for instance here, I can take -1 times 1/3 plus 0 times 1/3 plus 1 times 1/3, and I can see that the mean of x is actually 0. If we look at it, this makes sense. You know, there's an equal chance that it'll be -1, 1, or 0. 0 is in the middle. It's a discrete uniform distribution, if you remember. The mean is going to be 0. Okay, so there's our mean of x. Now we want to calculate the variance of x. Now again, the easiest way to do this is going to be to work with the marginal distribution of x. So I want to find the variance, sigma squared, of x. I can find the expected value of x squared and subtract my mean of x squared from it. So the expected value of x squared, I'm going to find by adding up over all the values of x, x squared times the marginal probability that x takes on that value. So in this situation, I'm going to have, let's see, -1 squared times 1/3 plus 0 squared times 1/3 plus 1 squared times 1/3, which is going to give me the expected value of x squared equals to 2/3. Now for my variance, sigma squared of x, I take my 2/3 and I'm going to subtract off my mean of x squared, but my mean of x is 0. So my variance is in fact 2/3. There's my variance of x. Okay, so now I want to find the marginal distribution of y. So for each value of y, I'm going to add up over all the possible values of x, the probability that x takes on that value, and y is the value I'm looking at, of course. So for instance, y equals 1, I add up the probability that y equals 1 and x is -1, y equals 1 and x is 0, and y equals 1 and x is 1. So I get 2/12. Whoop. Not sure why that happened. Should be getting 2/12. y equals 2, I get 2 twelfths plus 2 twelfths is 4 twelfths. And y equals 3, I get 1 12th plus 2 twelfths plus 3 twelfths is 6 twelfths. So this is 1/2, 1/3, and 1/6. And again, these probabilities need to sum to 1, and they do. Now to calculate the mean of y, I'm going to go through the similar process that I did with x. I'm going to sum over all the possible values of y times the marginal probability that y takes on that value. That's going to give me the mean of y. So let's see, just refreshing my memory here, I had 1 times 1/6 plus 2 times 1/3 plus 3 times 1/2, and that gives me a mean of 7/3. And also similar to the way I did with x, I can find the variance, sigma squared of y, by taking the expected value of y squared minus the mean of y squared. The expected value of y squared is the sum over all values of y squared times the marginal probability that y takes on that value. So this is going to give me 1 squared times 1/6 plus 2 squared times 1/3 plus 3 squared times 1/2, which gives me the expected value of y squared equal to 72 over 12. And then to find my variance, sigma squared of y, I'm going to take 72 twelfths, I'm going to subtract off 7/3 squared because that was my mean of y, and it's going to give me a variance of 5/9. Okay, I'm going to clear out some space so I can work on the covariance and the correlation. Okay, now to calculate the covariance. The covariance, the easiest way to calculate the covariance is usually to use the sort of what we call computational formula, which is that the covariance of x and y is equal to the expected value of x times y minus the mean of x times the mean of y. Now we know the mean of x and the mean of y, so what we really need to find is the expected value of x times y. So to find the expected value of x times y, we are going to add up over all of the xy pairs x times y times the joint PMF of x and y. So for instance, I can have x equal -1 and y equal 1. I'm going to have -1 times the probability that x is -1 and y is equal to 1. That's 1/12. Then I move on. Okay, I can have -1 and 2. -1 times 2 times the probability associated with that combination is 2 out of 12. And I move on, -1 and 3, multiply them, and then multiply by the probability of that combination, 1/12. And I keep going. I've got 0 here. Now, anytime I multiply x times y when x is 0, I'm going to end up with 0. So I don't really need to keep multiplying by those probabilities to get that part in. And then I have x is 1 and y is 1. So I have 1 times the probability associated with that, which is 1/12. Whoop, somehow I lost my, oh, no. Oh, yeah, it recovered. Okay. So let's see, I have x equals 1, y equals 1, and the probability that happens is, whoop, let me stop this one. Okay, so finally. Okay, fourth time's the charm, multiplying 1 by 1 and then by the probability that x is 1 and y is 1, which is 112. I have plus x is 1 and y is 2 times the probability that that happens, which is 0, plus x is 1 times y is 3, and the probability of that combination is 3/12. So when I add these all up, I get that the expected value of x times y is equal to 1/6. Now to find my covariance of x and y, I'm going to take my 1/6 and I'm going to subtract off the mean of x times the mean of y. My mean of x, remember, is 0. I'm going to multiply by my mean of y. So my covariance is 1/6. Now to find the correlation is calculated. We use the notation Greek letter rho, and it's equal to the covariance of x and y divided by the standard deviation of x times the standard deviation of y. So here we'd have our 1/6 divided by the square root of our variance, so the square root of 2/3, variance of x, times the square root of our variance of y, which is 5/9, and that's going to give us our correlation, which gives us about 0.27 for our correlation. Okay, now we're going to find the conditional distribution of y given that x is equal to 0. So the notation for this is h of y given that x is equal to 0. So we're saying, okay, now we're given that x is equal to 0. I know this is true. Now, what is the probability, if I know this, that y is equal to 1, y is equal to 2, and y is equal to 3? So the way that I figured this out is by remembering that the conditional probability of y given x is equal to 0 is the probability that x is equal to 0 and y is equal to y. So that would be f of 0, comma y, divided by the probability that x is equal to 0. So that's my marginal probability that x is equal to 0. So for each of these values of y, I can find this. So let's see, so h of y equal 1, given that x is equal to 0, is going to be probability that y is equal to 1 and x is equal to 0 is 0 divided by 1/3. So that gives me 0. The conditional probability that y is equal to 2, given that x is equal to 0, is a 2 out of 12 chance that I have x equals 0 and y equal 2. 2 out of 12 divided by a 1/3 chance that x is equal to 0. And this means the probability that y is equal to 2 given that x is 0 is 1/2. And similarly, the probability that y is equal to 3 given that x is equal to 0 is going to be 2/12. Probability that x is 0 and y is 3 divided by 1/3, which again gives me 1/2. So this is my margin, my conditional distribution. Okay, so now we want to calculate the mean of y given x equals 0 and the variance of y given that x equals 0. We have the conditional distribution of y given that x is equal to 0. And in order to calculate the conditional mean and variance, we need to use this conditional distribution. So all we're going to do to find the conditional mean of y given that x is equal to 0 we use the notation mu of y given x equals 0. We are going to add up over all of the possible values of y times the conditional probability that the random variable y takes on that value, given that x equals 0. So here we're going to say, okay, well, let's see, y could equal 1 times the probability that y equals 1 given that x is 0. Well, that's 0. Plus y could equal 2 times the probability that y equals 2 given that x is equal to 0, which is 1/2. And then y could equal 3 times the probability that y equals 3 given that x equals 0, which again is 1/2. And this gives us our conditional mean of y given that x is equal to 0 of 5/2. Now to calculate the variance of y given that x is equal to 0, whoops, I just wrote mean again, didn't mean to. Get rid of that mean and change it to the variance, sigma squared. I am going to calculate the expected value of y squared given that x is equal to 0, and then subtract the mean of y given that x is equal to 0 squared. It's the easiest way to do this computationally. So to calculate the expected value of y squared given that x is equal to 0, I'm going to add up for all the values of y squared times the probability, conditional probability, that y takes on that value given that x is equal to 0. So here this is going to be 1 squared times the probability that y equals 1 given that x is 0, which is 0. And y could equal 2, we'll take 2 squared times the probability that y equals 2 given that x is equal to 0, which is 1/2, plus y could equal 3, so 3 squared times the probability that y is equal to 3 given that x is equal to 0. And this gives me the expected value of x squared conditional on, of y squared conditional on x being equal to 0 is equal to 13/2. So now to find this conditional variance, I take this expected value of y squared that I found, 13/2, and I subtract off the mean of y given that x is equal to 0 squared, 5/2 squared, which gives me 27/4. And there's my variance of y given that x is equal to 0. So the biggest key is if you want to find the mean and variance of x, it is easiest just, not conditional on anything. It's easiest to work with the marginal distribution. If you need to find the mean or the variance of y given x or conditional on x, then it's best to use, in fact, it's necessary to use the conditional distribution. So hopefully this has helped clear up some of the sort of confusion about how to calculate these expected values and how to work with different distributions. If you have more questions, let me know. I do have office hours Thursday night from 7 to 8 online. There's a tab on Blackboard that will give you a link to the online office hours on Google Hangouts. Thanks. Have a good night or day.